Hello, we are going to discuss the Python program for the matrix addition, matrix multiplication, transpose of a matrix, and the trace of the matrix. So first let's discuss about the matrix addition. A matrix may be defined as a square or a rectangular array of numbers or functions that obey certain laws. The individual number of the array are called the elements of the matrix. The two matrices A and B are said to be conformable for addition if they have same order. If there are two matrices A equal to matrix Aij and B equal to matrix Bij, each of the order m star n, then the sum of two matrices A and B is defined as the matrix C equal to matrix Cij of order n star n, each element of which is the sum of corresponding elements of A and B. That is, A plus B equal to C if and only if Aij plus Bij equal to Cij for all values of I and j. So this is our program, matrix addition without number. First step is m comma n equal to input order of the first matrix, then p comma q equal to input order of the second matrix. In these two steps, we read the order of first matrix, and the second step we read the order of second matrix P and Q. Then next one, if M equal to P and N equal to Q, then go to step 4 or else go to step 23. That is, step 23 is a print matrix addition is not possible. If this condition is satisfied, define A equal to an empty set. Then print apostrophe enter person D elements of first matrix one by one, bracket row wise, apostrophe close and person close, bracket m star n. Then for I in range of m, row equal to an empty set. For j in range n, row dot append input. A dot append row B equal to an empty set. Print enter person D elements of second matrix one by one, row wise, and then apostrophe close percent P star Q. For I in range P, row equal to empty set. For j in range Q, row dot append of input. B dot append row C equal to an empty set. Again for I in range M, row equal to an empty set. For j in range n, row dot append of A I j plus B I j. Then C dot append row. And then so on. Type all these programs. And at last print, or else print not compatible for addition. And next step is the execution. We should run the program, and if the program is correct, we will get the result. Let's check go through the algorithm of the program. This is the algorithm. So if the step from step 5, if I less than m, then go to step 6, else go to step 10. Then step 6 is the if j less than n, then go to step 7, else go to step 9. Then if j plus 1 tends to j, go to step 6, or I plus 1 tends to I, go to step 11. Then 0 tends to I and 0 tends to j. Then if I less than m, then go to step 12, else go to step 16. The next step, if j less than n, go to step 14, or else go to the step 15. Step 13 is the read elements of second matrix. Many conditions are to be satisfied. And then step 19 gives S of ij equal to A of ij plus Bij. Then next step is to print the sum of ij. Then j plus 1 tends to j, go to step 18. Then if I plus 1 tends to I, then go to step 17. If not, then step 23 says that print matrix addition is not possible. Then last step, let's stop. That's all about the matrix addition without number. Then let's go through the matrix multiplication. The two matrices A and B may be multiplied together in the order of A, B only when the number of columns in A is equal to number of rows in B. Under this condition, matrices are said to be conformable for multiplication. If matrix A is of order M star H and B of order H star n, then the product C equal to AB is of order M star n. Its elements are given by Cij equal to summation k equal to 1 to h aik bkj. The Cij element, that is ij element of matrix C equal to AB, is formed as a scalar product of the ith row of A with jth column of B. The dummy index k takes all the values I 1, 2, 3, etc. h in succession. And these are the program. This is the program for the matrix multiplication without numbering. Just enter the order of the matrix, then enter the order of the second matrix. If n equal to p, enter the elements of first matrix, and then we have to enter the elements of second matrix. Then next step we do the matrix multiplication. Seventh step is print result, and next then we stop the program. So let's go through the program. M dot n comma n equal to input order of the first matrix, p comma q equal to input order of the second matrix, and then the condition if n equal to p, a equal to an empty set, then print, then for I in range m, row equal to an empty set, for j in range of n, row dot append of input, then a dot append of row, b equal to an empty set, again print, again some conditions are given. Then last you have to print or else print not compatible for matrix multiplication. And typing this program, let's run the program for the result. Next, trace of a matrix. Sum of the diagonal elements of a square matrix is called its trace. And this is the program for the trace to getting the trace of a matrix. So, trace of a matrix without number m comma n equal to input, enter the order of the matrix. If m equal to n, then give some conditions, and last print, or else if the condition is not satisfied, give print not a square matrix. Okay, first step is to enter the order of the matrix m comma n. Then if m not equal to n, print matrix is not a square matrix. Then I 0 tends to I and 0 tends to j. If I greater than n, go to step 9. If j greater than n, go to step 8. Enter element a of I, j, then j plus 1 tends to j, go to step 5. I plus 1 tends to I, again go to step 4, and so on. Okay, so after entering the program, let's run the program for the result. That's all about the trace of the element. Next we have to discuss about the transpose of matrix. A matrix of order n star m obtained by interchanging the rows and columns of a m star n matrix A is called the transpose of A and is denoted by the symbol AT. Then this is the program for the for getting the transpose of a matrix without numpy. First step, m comma n equal to input, enter the order of matrix. Then first enter the order of matrix m comma n, then 0 tends to I and 0 tends to j. If I less than m, then go to step 4, else go to step 8. If j less than n, then go to step 5, and else go to step 7. Then if j, then enter the element a, I, j. J plus 1 tends to j, go to step 4. Then 0 tends to j, and our I plus 1 tends to I, then go to step 3. 0 tends to j and 0 tends to I. If I less than m, then go to step 10, or else go to step 12. Then if j less than n, then go to step 11, else go to step 13. The next step, print a, j, I. When j plus 1 tends to j, go to step 10. I plus 1 tends to I and 0 tends to j, go to step 9 and then stop. And let's end by the print command. And then let's run the program for the result. Okay, that's all. Thank you.